The general form of an equation for a linear relation is ax plus by plus c is equal to 0. So what we've done is we've rearranged our entire equation to be on one side of our equation, to leave 0 on one side. But there's a couple things that have to happen. A must be a whole number. So that means it could be 0, 1, 2, 3. This means it cannot be negative, nor can it be a fraction. Okay. B and C can both be integers, meaning they could be negative. So -2, -1, 0, 1, 2, anything like that. But they also need to be whole numbers. So they cannot be a decimal or a fraction value. So A, B, and C must not be decimal places or fractions, and A has to be a positive number. So let's consider what happens in the general form of the equation when A equals 0. So let's put in 0 for A. 0 times x plus by plus c is still equal to 0. So 0 times x disappears, and we're just left with by plus c is equal to 0. If we solve for y is equal to -c divided by b. So if we were to graph that, we would see that it would appear at y equals -c over b, and it would just be a horizontal line. -c over b. All right, so what happens when b equals 0? So ax plus 0 times y plus c is equal to 0. So ax plus c equals 0, and x is equal to -c over a. So again, graphing, x is -c over a. So it is a vertical line at -c over a. Remember, a vertical line is not a function. So if b equals 0, it is not a function. If a equals 0, it can still be considered a function. So write each equation in general form. What we're doing here is we're just rearranging to get it to equal 0. So what I look at is it's easiest to just move y to the other side. So I'm going to subtract y from both sides. Y take away y is 0. And we're left with -1 over 4x. And I'm going to say take away y plus 3. Just to put it in the right order, where we have x, y, and then just a number. Now, it's all on the right side. However, we are not following the rules where the a must be a whole number and it must be positive. So to get this to be a whole number, 1/4, I need to multiply it by 4. So I'm going to multiply the entire equation, aka both sides, by 4. Now I'm going to be left with a negative still, because 4 times -1 over 4 is -1. So to mitigate that, I am going to multiply by -4. So -4 times 0 is still 0. -4 times -1 over 4 is +1. So I don't need to write the 1, I'm just going to write x. -4 times -y is +4y. And -4 times +3 is -12. So this will be our final answer here. Let's try it again. So y take away 2 equals 3 over 2x minus 4. What I'm going to do first is get rid of these brackets. So y minus 2, plus 2, is equal to 3 over 2x minus 12 over 2, which is 6. So I'm going to subtract 2 from both sides, and I'm also going to subtract y from both sides. That will leave me with 0. So 0 over here is equal to 3 over 2x. I'm just going to keep this in order. Take away 6, take away 2, take away y. All right, I'm going to reorganize to get it in our order. So positive 3 over 2x minus y, and then we have negative 6 and negative 2, which make negative 8. Our last task is to make sure that the coefficient in front of x is positive, which it is, and it's a whole number, which it is not. So to make it a whole number, we are always just going to multiply by the denominator of our fraction. So we will multiply, that's all equals 0 still. So we're going to multiply this entire thing by 2. So we're going to get 0 is equal to 3x minus 2y minus 16. Determine the x and y intercept of a line whose equation is x plus 3 plus 9, x plus 3y plus 9 equals 0. So our first thing I'm going to do is I'll find the x-intercept. And the x-intercept is when y equals 0. So let's put that in. X plus 3 times 0 plus 9 equals 0. So x plus 9 equals 0, therefore x equals negative 9. So our coordinate here would be negative 9 and 0. For our y-intercept, this is when x equals 0. So 0 plus 3y plus 9 equals 0. 3y plus 9 equals 0. 3y equals negative 9, and y equals, we need to divide both sides by 3, so we get negative 3. Our coordinate would be 0 and negative 3. So let's plot that. All right, I've gone ahead and labeled the axes of my graph. Knowing that we need to get up to an x value of negative 9, I've made my graph go up by 2's for each square. So just pay attention to that. So negative 9, 0 would be here. And 0, negative 3 would be here. And graphing through, make sure you draw a nice straight line. All right, I've tried to actually draw a straight line here because we're going to need it. We're going to verify that the graph is correct. Remember that means we need to select points on the line, and we're going to sub in those coordinates. So looking here, it looks to me like this point is directly on my line. The coordinates of that point would be 6, negative 5. So I'm going to sub those into my x plus 3y plus 9 equals 0 equation. So x was 6 plus 3 times negative 5 plus 9 equals 0. 6 minus 15 plus 9 equals 0, and 0 equals 0. Therefore, because both sides are equal, this is a point on the line, or the equation of the graph is correct. Determine the slope of the line with this equation. So what we need to do is we're going to move it into slope-intercept form. So we want to use y equals mx plus b. So we need to get y all by itself, and it has to be positive. All right, so for y to be by itself, I could just add 2y to both sides, and I get y all on its own. So I'm left with 2y is equal to 5x plus 12. I have just written our equation on opposite sides. All right, to get y by itself, I need to divide both sides by 2. So that means y is equal to, now, when two terms here separated by addition are divided by 2, it's like each term is divided by 2 itself. So 5x over 2 plus 12 over 2. We can separate these terms out, again, separated by their addition, and divide each term by the denominator of 2. We're left with y equals 5 over 2x plus 6. So the slope is equal to 5 over 2 in this case. Akiko is making a ribbon shirt. She has 16 centimeters of ribbon total that she will cut into 5 pieces. And those 5 pieces have 2 different lengths between them. 2 pieces will have the same length, and the remaining 3 pieces will also have equal lengths. So let's let the length of these 2 pieces be represented by x, and the length of these 2 pieces be represented by y. So what we're going to have is we're going to have some data for x, which is our input, and our y, which is our output, or just the 2 different lengths. So if the first lengths, 2, those first 2 lengths are cut at 0, aka we don't cut them at all. Those remaining 3 pieces to be divided into 60 centimeters must have a length of 20 centimeters. Now, I also know that if those pieces have a length of 0, so those 3 pieces here are cut at 0, aka we don't cut them, the other 2 pieces must have a length of 30. Now, you might be able to guess this last one, or you would have trialed and errored, or whatever it is, but if these 2 pieces have a length of 15, that means I've used 30 centimeters of my ribbon out of my 60. I have 30 centimeters remaining, divided by 3 equal pieces is 10. So this was a little bit tricky, and this is what we look at great length in kind of our next unit, is writing an equation and looking at word problems like this. So don't be alarmed if this was tricky. So we're going to graph our data down here on our graph. So I'm going to graph y by x, and I'm just going to label my axes here. All right, labeled my axes. Let's graph this data. So x equals 0 and y equals 20. We have x equals 15, y equals 10. Ooh, this is really hard for my eyes to look at. Okay, and 30 and 0. And we're going to connect those with a nice straight line. All right. Now we're going to write an equation for this relation in general form. So we were kind of given this equation in general form to begin with. So we can say that 2x, so 2 times the length of x plus 3 times the length of y is equal to the 60 centimeters of ribbon that we had. Now, to get this in general form, I just need to subtract 60 from both sides. So 2x plus 3y take away 60 is equal to 0. We could have also written an equation of the line using our slope-intercept form and been able to work backwards into general form as well using our graph. All right, can 2 pieces of 18 centimeters long each and 3 pieces of 3 centimeters long work? The sentence is terrible there. Okay, well, there's 2 ways we can look at this. We can sub into our equation where the 2 pieces, remember, their length is represented by x, and the 3 pieces, their length is represented by y. So x equals 18 and y equals 3. Let's try that. So 2 times 18 plus 3 times 3 minus 60 equals 0. 2 times 18 is 36. 3 times 3 is 9. Take away 60 equals 0. And when I add up everything on one side, I get negative 15 equals 0. That is not true. Therefore, no, this is not on the line. Another way we could have looked at that is we could have plotted it. So x equals 18, y equals 3. This point is definitely not on the line. So let's try the other one. If we cut the 2 pieces to length x and the 3 pieces to length y, will it work? Let's sub back in. So 2 times 3 plus 3 times 18 minus 60 equals 0. 6 plus 54 minus 60 equals 0. Does 0 equal 0? Yes. Therefore, yes, this point is on the line. We can also graph it. I'm going to graph it in yellow here. So x equals 3, y equals 18. You can see that this point is on the line.